The L function can be obtained by the subordinate Zeta function of the binomial theorem of the Zeta function, and the L function can be inverted again by the functional equation. The difference between the subordinate Zeta functions 3, 1 and 3, 2 is the L function chi1 of mod 3, and if inverted by the functional equation, the L function can be obtained by the Zeta function of the negative domain. The functional equation of analytic continuation is possible only when the Dirichlet character is primitive. The L function chi1 of mod 3 is a primitive character, and the L function chi1 of mod 6 is induced from the L function chi1 of mod 3. Therefore, the L function chi1 of mod 6, which is the difference of the subordinate Zeta functions 6, 1 and 6, 5, is equal to the L function chi1 of mod 3 of 1 plus 2 to the power of minus s. In addition, the sum of the subordinate eta functions 3, 1 and 3, 2 is not an L function, but is 2 to the power of minus s, the L function of mod 3 plus the L function of mod 6. Therefore, the sum of the subordinate eta functions 3, 1 and 3, 2 is the L function of mod 3 of 1 plus 2 to the power of 1 minus s. In this way, if only the L function chi1 of mod 3 is inverted by the functional equation, the induced L function and the extended L function of eta function can be derived. Therefore, the non-trivial zeros of the L function of mod 6 and the sum of the subordinate eta functions 3, 1 and 3, 2 are the same. If the binomial theorem of the zeta function and eta function is inverted, it expands to the negative zeta function and trigonometric function, but if the inversion of the gamma function is applied, the trigonometric function can also be eliminated. Therefore, the inversion of L function of mod 3 by the functional equation expands only to the negative odd zeta function, and it is established in all regions. With the expansion up to 70 terms of the negative zeta function, it matches the Hurwitz zeta function 1/3 minus 2/3 to 13 decimal places at s equals 1/2, and even if the imaginary part A is increased, it shows an error of more than 8 decimal places. When calculating the inversion of the L function chi1 of mod 3 with 800 terms of the zeta function using Wolfram alpha, it is the same as more than 40 decimal places. In the inversion of L function chi1 of the mod 3, the alternating sum of 70 terms of the negative zeta function is more accurate than the error of more than 4 decimal places of the reciprocal gamma function due to the product of 10,000 terms by Weierstrass definition. In addition, the product of 10,000 terms and the alternating sum of 70 terms are not comparable in computing time. The alternating sum of the negative zeta function of the inversion of L function of mod 3 shows that the trivial zero of the L function of mod 3 is located at a negative odd number due to the trivial zeros of the zeta function. The Riemann hypothesis ends with the generalized Riemann hypothesis, and the zeta function and L function with non-trivial zeros on the critical line are invertible. The inversion of L function of mod 3 shown in GeoGebra belongs to the most condensed form of the generalized Riemann hypothesis, and the generalized Riemann hypothesis is proven if it can be shown that there must be a non-trivial zero on the critical line, or if the non-trivial zero of the critical line can be derived. The minus 2/3 to the s power plus 2/3 to the 2k power of the negative odd zeta term obviously affects the non-trivial zero, but it does not create the non-trivial zero by itself. And the non-trivial zero is created by the alternating sum of negative zeta function. One possibility, I think, is that the alternating sum of negative zeta function can only be symmetrical on the critical line, and other inversions of L function can show the same form. It is all speculative, but there is a possibility for the proof of Riemann hypothesis. The GeoGebra formula allows anyone to compute the non-trivial zeros of the L function and challenge the proof of Riemann hypothesis. Better formulas and mathematics may prove the Riemann hypothesis explicitly. However, it is first necessary to compute all functions related to the Riemann hypothesis, such as the zeta function, eta function, and L function in the negative and positive domains.